Welcome back to the EdgeVerse Techcast, your go-to spot for all things edge computing, embedded development, AI, connectivity, security, and more.
Yeah, today we're going to cover one of the most exciting applications, and that's Edge AI. We've had a few episodes on this, but today we're going to talk about voice technology and how that is starting to adopt Edge AI, specifically in smart glasses.
And as AI becomes increasingly conversational, smart glasses are emerging as a compelling platform for delivering always available assistance without constantly pulling out a phone or looking at a screen.
But Bridget, it's a little bit more complicated than that. The problem that engineers are trying to solve is how does it seem natural to the people listening? They have to solve challenges around latency. How do they recognize speech, audio quality, power consumption? There's so many other challenges that they have to meet to make this a reality.
That's right. And to help us unpack all of this, we're joined by Laurent Pilati, who recently presented NXP's keynote at AWE, The Sound of Smart Glasses, bringing voice AI into the real world. Laurent, welcome to the EdgeVerse Techcast. But before we dive in, can you tell our listeners a little bit about yourself and your role at NXP?
Sure. Thanks, Bridget. I'm leading the AI software team in the ACE organization. So why an AI software team? The reality is quite simple. A standalone model, like you take a simple ResNet, does not longer create business value on its own, right? So the real opportunity is turning AI into an integrated solution that deliver real business impact. That's exactly where we are focused on. We are bringing together our expertise, aligning our efforts, and concentrating our innovation around the same platform, same use case, and same customer. This unified approach truly enables synergy across key AI domains, which are the vision, the voice, GenAI, physical AI, and agentic AI. And together, this is how we go from features to real intelligent systems.
Well, great to have you here, Laurent.
Yeah, and before we jump into some of the details, why don't you step back and paint a little bit more about that big picture? Laurent, it seems like every day at work, I hear more and more about these AI assistants. But now we're talking about smart glasses. Why is that generating more excitement? And what makes them different from other wearable devices?
Yeah, I think what makes smart glasses so exciting is that, they have the potential to become one of the most natural interfaces for AI. Because for years, we have interacted with technologies through screens, and whether it's a phone or a tablet or computer, we had to stop what we are doing and shift our attention to the device, right? But smart glasses, they create the possibility of accessing information, communication, and AI assistant without that interruption, right? And as AI become increasingly conversational, voice is becoming a primary interface. So smart glasses are truly uniquely positioned to take advantage of that because they're always available and they don't require you to pull out a device or constantly look at a screen. From developer perspective, there is also one of the most challenging Edge AI platforms because you are combining vision, audio, voice processing, wireless, power constraint, and industrial design into a very compact form factor where the design matters. That's what makes them such an exciting area for innovation.
And I think a lot of developers understand the appeal, but they may not realize how difficult it is to create an experience that actually feels natural. In your keynote, you talked about concepts like latency, Barge-In, backchanneling. Can you go into why these are so important and what makes a voice interaction feel more like a human conversation than a command?
Well, this is really where conversational AI becomes different from a traditional voice assistant. Human conversations are incredibly dynamic. You don't wait for someone to finish speaking before you react, right? We acknowledge that we are listening. We interrupt when appropriate and when we naturally move back and forth, right? Backchanneling is a good example. Small responses like, yeah, right, for sure. They are just here to keep the conversation flowing, but that does not expect explicit answers, right? Barge-In is another important capability. It allows the user to interrupt naturally when they want to clarify or steer the conversation in a new direction. Latency is also critical. humans are very sensitive to delay in conversation. Even a few hundred milliseconds can make an interaction feel unnatural. For developers, that means you have to optimize the entire system, the audio capture, audio processing, the wireless connectivity, the AI inference time, cloud communication, and audio playback. They all contribute to the user experience. And ultimately, the goal is not just recognizing speech correctly. The goal is making the interaction feel natural enough that users stop thinking about the technology.
Okay, you did a great job establishing what good experience looks like and some of the challenges that have to be tackled. But the next thing that maybe we should address is what's helping the device actually hear what's going on in the real world. Now that we're using glasses to hear what's going on, these smart glasses have to operate in airports and restaurants, trade shows, city streets, basically anywhere where there's tons of noise and interference. So how does NXP help developers capture and understand the expected speech in those noisy environments?
Yeah, and that's one of the biggest challenges in wearable audio, right? In the laboratory environment, speech recognition is relatively easy, but the real world is much harder. You've got background conversation, traffic noise, wind, music, all kind of competing sounds. And that's where technologies like the beamforming become important. Beamforming uses multiple microphones to focus on a particular sound source. In smart glasses, we can focus on the wearer voice with fixed beamformer while reducing unwanted noise from the surrounding environment. We can also use adaptive beamforming techniques to focus on other speakers when needed, which is useful for applications like translation or conversational assistant. On top of that, we use echo cancellation and speech enhancement technologies to improve the quality of the audio before it reaches the speech recognition system. The result is better speech recognition accuracy and a much more reliable user experience in real-world conditions.
And of course, all that processing doesn't happen for free. Developers also have to think about battery life and system structure. So let's talk a little bit about the hardware and software inside. What building blocks does NXP provide to help developers create voice-enabled wearable devices without starting from scratch?
Yeah, indeed. One of our goals is to provide developer with a complete voice and audio solution rather than just individual technologies. So with Conversa and EAP, we offer software building blocks for beamforming, echo cancellation, speech enhancement, audio playback, and all other critical voice processing functions. These technologies are designed to work together as a cohesive framework for wearables, which help reduce development complexity and accelerate the time to market. On the hardware side, devices like the i.MX RT700 are particularly well suited for wearable application. Reason is the RT700 combines DSP resources, neural processing capabilities, and low power compute domain that allow developers to run sophisticated voice and AI compute while maintaining excellent battery life. The ability to keep voice-related processing active in a low-power sensing domain is especially important for always-on conversational experience. And finally, at NXP, we validate our voice and audio solution in NXP Audio Lab. Together, the hardware and software create a platform solution that developers can build on rather than having to assemble everything from scratch and solving fundamental audio processing challenges.
So, Laurent, for developers that are listening right now, what advice would you give them if they're interested in using this platform to build their own conversational AI experiences, or if they're looking to develop products like smart glasses or maybe a wearable application?
Well, I would encourage developers to start with the user experience. You know the famous quote, you have to start from the customer experience and work backwards to the technology. Because it's easy to focus on AI models, on processing powers, but users ultimately care about whether the experience feels natural. So think about the latency, think about the audio quality, think about how the user interact with the system through their day, right? and then work backward to derive the technical requirements. Another recommendation is to take advantage of existing framework and software building blocks. Voice and audio processing involve a lot of specialized expertise, and leveraging proven solution can significantly reduce development effort. Finally, remember that conversational AI is still evolving rapidly. Smart glasses are just one example where these technologies are deployed, but the same principle apply to robotics, automotive, and many other edge AI systems. Typically in robotics, we are today building the next generation of intelligent robots, which combine voice also for conversational AI in humanoid. On top of that, we are adding other AI like the vision for navigation, physical AI to control the robot, and the agentic AI to enable autonomy on those robots. So we are still in the early stages, which makes this an exciting time for developers to get involved.
Well, Laurent, thanks for joining us today and sharing a lot of the insights from your AWE keynote.
Thanks for having me on the show.
Yeah, Laurent, it's been really exciting to hear what you've been doing with voice processing, what NXP has been enabling. There's a lot of audio engineering that you covered today, and obviously the tie-in with Edge AI that pulls everything together. You've talked to customers and obviously our listeners today about how that is now creating this natural interaction. When people put this technology on, they're getting that experience that they expect.
And to our listeners, if you'd like to learn more about NXP solutions for Edge AI, voice processing, and wearable applications, be sure to check out the resources linked below.
And if you enjoyed this episode, don't forget to subscribe to the EdgeVerse on YouTube, Spotify, Apple Podcasts, or wherever you're downloading this episode, so that you will never miss a conversation that Bridget and I hold.
Thanks for listening, and we'll see you next time on the EdgeVerse Techcast.